Our understanding of reality is rooted in our consciousness. Our ability to be aware of our own existence forms the foundation of logic and reasoning. The simple fact that we are conscious allows us to navigate the world, make sense of our surroundings, and engage in meaningful thought. The very act of being aware of ourselves means that we can affirm one basic truth: we cannot exist and not exist at the same time, within the same context. This awareness is the cornerstone of our logic, and from this point of certainty, we begin to construct further beliefs about the nature of reality. However, this logic does not guarantee that what we experience is the full truth of reality. It is merely our way of making sense of the world through the lens of our perception. Our experience of reality, while undeniable, is limited. It represents only a fraction of what might exist in the greater schema of things. What we call real is constrained by what we can perceive and comprehend through our senses and minds. This experience is shaped by both our biological nature and the evolutionary pressures that have honed our ability to survive in a world full of danger and uncertainty. Over millennia, the human brain has adapted to recognize patterns and make predictions based on what has worked for our survival. In this way, we have learned to navigate and interpret reality in ways that increase our chances of survival, but this interpretation is not necessarily the full or absolute truth. It is yet another story that makes sense within a given framework. The interpretation of reality has evolved over time, and the methods by which we explore it, be it through religion, philosophy, or science, have sought to describe it in increasingly sophisticated ways. The scientific method, in particular, allows us to measure and test what works within the bounds of our experience. However, while the scientific method provides reliable results, it is important to remember that these results are still based on our limited perspective. Quantum mechanics, for instance, reveals a reality that is not always measurable in conventional terms, with phenomena that defy our classical understanding of the world. It suggests that reality behaves in a way that can seem unpredictable or even incomprehensible, depending on the observer's perspective. One of the most profound insights that quantum mechanics offers is that reality doesn't necessarily operate the same way at all levels. Our experience of time, for example, is shaped by our perception of change and continuity. Time, in our daily experience, seems to flow from one moment to the next, but in a deeper sense, time may be nothing more than a tool we use to organize our actions and experiences. It is not an intrinsic property of the universe, but a construct that helps us navigate our existence. Our brains interpret time based on our own experiences, which are shaped by change, but this does not mean that time is a fundamental aspect of reality in and of itself. Ultimately, our understanding of reality is shaped by the stories we tell to explain how things work. Humans are natural storytellers, and our theories, whether in science, religion, or philosophy, are narratives that help us make sense of the world. These stories are useful because they allow us to predict and manipulate our environment, but they do not necessarily correspond to an ultimate or absolute ontology. Our experiences represent just one subset of a much larger, more complex reality. The limits of our observation, such as the Planck's scale, where our current understanding of physics breaks down, demonstrate that there is much about reality that remains beyond our grasp. In the end, while we can build useful models to describe the world, these models are merely approximations, stories that help us make sense of the unknown